Problem number 16. Find the largest integer n such that n squared plus 5n minus 9 486 equal to 10 times s of n, where s of n is the product of all digits of n in the decimal representation of n. For example, s of this is this. Okay. So for example, when we have this one, I want to say for large n, left side will be greater, right side cannot be a great number. So I want to say s of n is at most what? If n is one digit number, for example, n is a, then we can say s of a is also a is equal to n. If n is ab, then let me write ab, then S of n is a times b, and n is what? Number ab, which is 10a plus b. Now, because here a multiplied by 10 and plus some positive, here a multiplied by b. And we know it is, this one is less than this one. Why? It is equivalent as 0 if you take it to right hand side and factor from a. 10 minus b plus b. A is positive, 10 minus b is positive, so it is strictly greater than 0. So after one digit numbers, you will understand. Also, if you check, for example, 3 digits, and easily you can prove for n. For when we have, for example, m digits. S of n, for example, it will be a, b, c, and L will be 1000a plus 100b plus c. Again, we say this is strictly greater than this, because if you take it to right side, it will be a times 1000 minus bc plus 100b plus c. It is greater than 0 because bc at most 81. It is strictly greater than 0. Now here we conclude what? We can say, okay, n squared plus 5n minus 9486 equal to 10 s of n. This one, it is less than, so look at the problem, says find largest integer n, or we can also write less than or equal 10n, not important. So n squared minus 5n minus 9486 greater, less than or equal 0. I've taken 10n to the left hand side, it will be negative 10n. Now here we want to solve n is in what intervals? Okay, we don't need to find a specific answer here. If we replace, for example, n with 100, then here we have what? 10,000 minus 500. 10,000 minus 500 is 9,500. Minus this, it will be positive contradiction, and we know it is increasing for n greater than 5. So we understand that n is at most, because the problem says find maximum n. We found that n is maximum of n is 99. Okay, so for example, for this problem, if you check 99, it works. But let me tell you a better way. If you want to solve this one, we know, for example, for a small n, it doesn't work. For example, 1, it will be negative, 2, negative, until we want to see what number it is negative. So we know it should be greater than 0, positive, because 10 s of n is positive. Also, you can say greater than equal to 10. Now, if you replace, for example, here 90, then it will be what? 90 squared plus 5 times 90. It will be this, it will be this number plus this. Now, we will see it is negative for 90, so we understand n is at least 91. Okay, so we understand that Sn we want to find is 9 times, for example, a digit here. We can say, for example, b, this number. So if we want to find this, if we consider mod 9, then n squared we have plus 5n mod 9. This one will be 0 because sum of the digit is 9 plus 12 plus 6, 18 plus 9, 27. It will be this one will be 0, and right side at 10 s of n, it will be 0 because 9 times b is 0. So mod what? Mod 9. So we can say 9 divides n squared plus 5n. So we can say 9 divides n times n plus 5. So 9 divides n, or 9 divides n plus 5. So here, if 9 divides n between 91 to 99, 99 is the case. If 9 divides n plus 5, n will be 94. The problem says find the maximum. So we want to prove that 99 works. So 99 squared plus 5 times 99 minus 9486 equal to 10s of n times 9 times 9. Now, okay, we want to prove this. At first, we divide both sides by 9. It will be 11 times 99 plus 5 times 11, 55. If we divide by 9, minus 1054. We want to prove why it equal to 9. Okay, if we multiply this, it is equivalent that 1089 plus 55 minus 1054, why it equal to 90. This number minus this number, 9 minus 4, 5, 8 minus 5, 3, 35 plus 55. Here, it will be what? 80, 90. And it's satisfied, and it's the greatest number. So the answer of this problem equal to 99.